Alright, so this time we're going to work on P5.7 optics of curved mirrors. We're going to look at number 1, and I'm going to kind of go through exactly how I got everything that's written here in the box. So first off, when you look at a concave mirror with a radius of curvature of 1.9 millimeters, you have to find the focal length by using the equation F is equal to R divided by 2. So we'll use that over here, as you can see, and then we'll get that 1.9 divided by 2 is 0.95 for a focal length. It tells you that the object is located at 3.5 meters from the mirror, so then that means we'd put 3.5 in here. The equation is going to be 1 over F minus 1 over XO is equal to 1 over XI. Something to note, this guy is an inverse relationship to XI. It's the reciprocal, so to solve it we are going to do 1 over in the calculator, then do in parentheses 1 over 0.95 minus 1 over 3.9. When you put that in the calculator, you should get 1.26 meters. Notice that the image is located closer than the object, and that's what we're looking for there. Now we need you to go ahead and pause the video, try number 2, and then we will go over how you would do number 2. Alright, this is what you should have seen on number 2. We go ahead and use our equations. R is equal to 20, so we find that F is equal to R divided by 2, or 10. So we'll use that into this portion here. So as you look over this here, I put that 10 there. And then also the XO, it tells you the symmetry, on the symmetry of axis, the mirror is located 30 meters from the mirror. The object is located 30 meters from the mirror, so you would put that in here for XO. XO. Remember that for XI, it's 1 over XI, so we want to go ahead and put that 1 on the other side so that we can find the reciprocal of the answer, and that'll give us our image distance. And you should have gotten 15. Alright, let's move on to number 3. Alright, so we're looking at number 3, and it's one of 3 parts, so we will look at part 2 for number 4, and then part 3 will be number 5. When we're looking here, the very first thing you should note, it says it has a focal point of 39 centimeters. This differs from number 1 and number 2 because you do not have to find it from the radius of curvature. It is just given to you, so you can go ahead and write that the focal length is 39 centimeters. Then it wants you to calculate the image, so we're still solving for XI, and it tells you that the distance of the object is 83 centimeters from the mirror. So you can go ahead and enter that in. Now you're going to see that you will have this equation here. Again, 1 over F minus 1 over XO is equal to 1 over I. Don't forget you have to solve for the reciprocal of this, so we'll go ahead and enter it in as such. You'll note here that F is 39 and XO is 83. Make sure you put 1 divided by, parentheses 1 over 39 minus 1 over 83, close parentheses, and you should get 73.6. Because this guy is a positive value, you'll note that it is a real image. Alright, so one of the next things we'll go on is, now that you know the image distance, you can plug that into this equation. When you look at that, it should be negative XI divided by XO. Okay, so that should then tell us some things. Because of the negative sign, that means the image will be inverted. And because the magnitude is less than 1, not because it's a negative, but because it's a decimal place that is less than 1, means that the image will be smaller. So that should help you through that. And then finally, anytime the distance of the image, or the object's distance is at the focal length, where in this case it gives you an answer of 0, there is no image. So the last one, make sure you show your work there, and that should be everything you need. Go ahead and work on the back by yourself, and then we will make sure you turn it in when you can, as soon as you can.